Hey everyone, welcome to your last recitation worksheet video. So in this one we're going to go over a bunch of topics that you can expect to see on upcoming exams. So for our first problem over here, we're going to be doing some binary and hex conversions. Before we dive into that, let's sort of go into like what binary and hex are. So we're most used to seeing numbers in the decimal format, right? So decimal is base 10. Whereas binary and hex are base 2 and 16 respectively. So binary is base 2, and hex is base 16. So binary is used by the computer at a deep level for processing electrical signals, right? Because you can only have values 0 and 1, and to the computer those represent a signal being off or a signal being on respectively. Similarly for hex you've actually seen in this class before. If you remember, if you ever used a CSS color code in your Lab 1 project, you may have seen something that looks like this, for example. So this right here is the color white, but it's actually a combination of 3 values, and each of these is a hex value. So binary and hex are very useful in computer science, and we should know how to convert between decimal to binary and binary to hex and all the other possible combinations. So let's sort of go ahead and try an example where we use a decimal number and convert it to a decimal number. And that may not make much sense because it's already in decimal, but if we can work with an example that we fundamentally understand, we can sort of get a better idea of what we're doing when we convert from decimal to binary or decimal to hex. Okay, so let's start off with 172, and let's convert 172 to decimal, right? Now, if I'm given 172, the sort of strategy that we're going to use for all of these conversions is we're going to pick the base number. Okay, so in this case, if I'm converting to decimal, my base is 10, right? So I'm going to start off writing off a blank. Okay, and this is going to be my 10 to the 0 spot. Okay, also known as 1, right? Then I'm going to bump up the power of 10, so 10 to the first, 10, and then 10 squared, 100, and basically keep doing this until you reach a number down here that is greater than the number that you're trying to convert. So 100 is not greater than 172, so I'm going to bump up the power again, and now I get 1000, which is definitely greater than 172. So now we have to ask ourselves, we're going to go, so we went from right to left, now we're going to go back left to right. So how many times does 1000 go into 172? Well, obviously 0 times, right? Because we went until we could find a number that was bigger than this. So this 1000 does not go into 172, so we're going to put 0 there. Now, how many times does 100 go into 172? Goes in 1 time. How many times does 10? Oh, and by the way, when you're doing these conversions, every time you put a number into a spot, you have to subtract the number you put in times that position. So in this case, I'm going to subtract 1 times 100, which is just 100, and I have 72 left over. Now let's ask ourselves, how many times does 10 go into whatever's left over here? And it goes in 7 times, right? So then I can subtract 7 times 10. I get 2. And now we have to ask ourselves, how many times does 1 go into 2? Goes in 2 times. Then I can subtract 2, and I reach 0. So there's nothing left in my number to position. So in this case, my conversion yields 172, and because we don't need a leading 0, this is the exact same as saying 172. And what's nice is this technique that we just did of writing out all the bases until we reach the largest one and then going backwards works for all of these systems. It works for binary and hex. So now that we've done this for decimal to decimals, so we can get a fundamental understanding of what these number bases are, let's actually try to do this with decimal to binary. And then for the rest of them in the table, we'll just zoom through after we've like officially learned the technique. So now we can convert 172 to binary using this exact same technique, where we're going to write out all the slots per se, and then fill them in backwards order, starting from greatest to least. So we're going to start with 2 to the 0, which is 1. And then rather than writing out 2 to the first, 2 to the second, so on and so forth, I'm just going to keep doubling them, because that's what happens when you raise by a power of 2, right? So 2 to the first will be 2, then 4, then 8, 16, 32, 64, 128, just keep going, and then 256. Okay, so I've reached a point where this base right here, 256, is greater than 172, so I don't need to keep going anymore. And I can automatically fill this in with a 0 because I know that 256 cannot fit into 172. Now I can work my way back down, trying to fill in the largest number that can go in here. And keep in mind, you should only be getting either a 0 or a 1 for any of these slots. And that's because we're dealing with binary. We can only have 0 or 1. So can I fit 128 into 172? I sure can. So I'm going to put a 1 in here, and then I'm going to subtract 128. So minus 128, and I believe that is 44. Okay, so now we're dealing with 44. So can I put 64 into 44? I cannot, so I put a 0. Can I put 32 into 44? I can. Put a 1, subtract 32, get 12. And you don't need to necessarily do this repetition over and over, because once the number is small enough, you can very easily figure out how you can allocate these remaining numbers. So in this case, I know that 8 and 4 will make 12. So I can just put 1, 1, and when I take away 8 and 4, 8 and minus 4, sorry about the slant, you'll get 0. And that means I can just fill in the rest of the spots with 0. You could have also just continued doing the same technique down the chain. So you could have said, does 16 go into 12? No, put a 0. Does 8 go into 12? Yes, then subtract, so on and so forth. So yeah, either way works. So now we have this, and we can just sort of condense this whole thing down. So it's 0, 1, 0, 1, 0, 1, 1, 0, 0. And just like when we did our conversion with 172 to decimal and we got 0172, leading zeros don't really matter, right? So in this case, we can actually just go ahead and trim off that first 0 we got, and this will give us our final answer. So that right here is 172 in binary. So let's go ahead and write that down in our table. 1, 0, 1, 0, 1, 1, 0, 0. So to convert decimal to hex, we can do the exact same thing. And I'm going to show you a cool technique that actually makes converting from binary to hex extremely easy. It's very quick, but just for knowledge's sake, we should do the exact same thing. Okay, so now we're doing 172 to hex. So let me write that down. We're going to do the exact same technique, right? You'll see there's a lot less slots this time. So we have 16 to the 0, which is 1. We have 16 to the first, which is 16. And then we have 16 squared, which is 256. So we've reached a point where our number is indeed greater than the number we're trying to convert, so we can just put a 0 here. And now we have to start doing some math. So we have to ask ourselves, how many times does 16 go into 172? Go in 10 times, right? Because if I subtracted 10 times 16, 160, 172 minus 160, I get 12, right? So that tells me I can't fit another 16 in there because 12 is smaller than 16, so I need to put a 10 here. Now here's the interesting part. You can't just put a 10 in hex, right? So we have other characters to denote numbers that are greater than 9 in terms of digits. So as usual, we have 1 to 9, and then we also have A is 10, B is 11, C is 12, D is 13, E is 14, and then finish off at F being 15. And notice, and this should be a 0, actually. So from 0 to 15, that is 16 total digits, hence base 16. So we said 10 over here, and if I look into my key, I can see that A is my 10, so I can just put an A here. And then I'm dealing with 12 more available slots to fill, I guess. So here we have to ask ourselves, how many times does 1 go into 12? And the answer is, of course, 12, right? So subtract 12, get a 0, nothing left over. So I look for 12 over here because 12 is greater than 9. So I have to find one of these letters. And in this case, it's C. So I just put C. This becomes 0AC. As usual, zeros are not relevant when they're in the leading position. Definitely always keep zeros if they're in the trailing position. So a 0 here makes a big difference. And anyways, that is my final answer, AC. So we've done the first row of this table. Now, one interesting thing that I want to show you is a very, very quick way to go from binary to hex. Going from decimal to hex can be a little bit tedious, especially if you're dealing with large powers of 16 and there's more math to do, and as a result, you can go wrong in more places. But if you do binary to hex, it's a lot quicker. So let me erase all this stuff and then we can see an example of how quick that is. So let's say you were given a binary number or you already converted the decimal to a binary number. What you want to do is write out your binary number and then start writing it from the right side. So I would start from the 0 and go to the left. And then every time you hit 4 characters, separate them out. So in this case, I have 0, 0, 1, 1. That's 4 characters, so I'm going to separate them. And then what's next? 0, 1, 0, 1. That's 4 more characters. So had there been 3 more characters left over after this first 4, it wouldn't really make a difference. I would just fill it in so that there's a 0 in the front. The point is that you want to make groups of 4. You want to make groups of 4 starting from the right side. Okay, so with that, we can now easily convert from binary to hex with these groups just by converting these groups of 4 into individual numbers. So this would be 1, 2, 4, 8. So this is just 4 and 8 because I have 1s in these spots. So that's 12, right? And then I ask myself, what is 12 in hex? And it's C. Cool. Now what about here? 1, 2, 4, 8. I have something in the 8 spot. I have something in the 2 spot. So that's 10. And then what is 10 over here? It's A. So this comes down to being AC. So that's a strategy right there. Do decimal to binary first, and then you can work your way backwards very easily. So now that we've done that, let's go ahead and do the next rows using these new techniques. We're not going to go into as much detail since we already covered it in depth over here. I'm going to keep this legend on the side just because it's pretty helpful to have as reference for hex. So here we have, here we have a binary number, okay? And notice it is not going to evenly divide into nice groups of 4. So this is a good example. So the first thing we can do is we can convert this to decimal, okay? Let's see. So I'm going to write down 1, 0, 1, 1, 0, 0. And then I put in my powers of 2 right below it, and then I just add them up wherever there's 1. So 1, 2, 4, 8, 16, 32. So wherever I see a 1, I add. So here I have 1 here, plus 8, plus 4. Okay, and in this case I get 44. So let me go ahead and write that here. And then now we're going to do our fancy trick to convert from binary to hex. So erase that, erase that. So once again, we're going to group by 4 starting from the right. Okay, that right there's a group of 4. And then here I have 2, so I'm just going to put in 2 more zeros. Remember, leading zeros do not matter. There's another group of 4. And I'm going to convert each of these into decimal and then find the appropriate number over here. So we have, this is 8, 4, 2, 1, so that is 12. And then this is 8, 4, 2, 1, that's just 2, right? So we have 2 and 12, so that means 12 is C, so 2 and C. And the reason that this trick works is because notice that if you were to add up 8, 4, 2, and 1, what would you get? You get 15, right? It's the exact max capacity. So that means this block of 4 can go anywhere from 0 to 15, which is exactly like a single digit in hex, right? A single hex digit can go anywhere from 0 to F, which is 0 to 15. So that's why this trick works in the first place. All right, so now that we've gotten the second row out of the way, let's go ahead and do that last one. Then we can be finished with number conversions. Delete. Okay, so here we've been given a hex number to start with, and we can convert to decimal and binary. So let's just go ahead and say 7. So remember, this is 16 to the 0 spot, and this is 16 to the 1 spot, right? So A is 10, B is 11. So we have to multiply 16 by 11 plus, this is just 7, so 7 times 1, so plus 7. So 16 times 11 is 176. Add on the 7, and then we'll get 183. Great, so I will write down 183 over here. And then to convert this to binary, we'll just start with the same hex over here. So we'll say B7, and then all we have to do is just convert each of these into binary. So B is 11, 7 is still 7, and then let's just convert each of these numbers into binary and then smush them together. So what is 7 in binary? So if I have 8, 4, 2, 1, to get 7, I would have to add the 4, the 2, and the 1, right? So this is 0, 1, 1, 1. And then to convert 11 into binary, we'll do the same sort of thing. 1, 2, 3, 4. 1, 2, 4, 8. I can add 8 plus 2 plus 1, that'll be 11. So 1, 0, 1, 1. And then I can just smush these two together. So my final answer should be 0, 1, 1, or 1, 0, 1, 1, then 0, 1, 1, 1. Let me write that down over here. Okay, so that is how to do all the numerical conversions. As I said before, it's very easy to go from decimal to binary and then binary to hex. Hex to decimal or hex to binary, there's no entirely good way to do that. So it's just a matter of personal preference for you, but this is the way that I like to do it. So now let's go ahead and go to the next problem. So the next problem we're dealing with is a recursive problem. We just have to find out what would be printed to the shell after this whole code is run. And I'm going to be doing the same technique I did in the recitation video on recursion. So if you haven't seen that already, I strongly recommend that you watch it because I won't be going into as much depth of what I'm doing this time. Just going to be running straight through it. So we're going to go ahead and start at the function call. So this is my original function call. Let's go ahead and write that out. So, and then for brevity's sake, I'm not going to put the quotes around the string because we know they're strings. CA PT, okay, Z, that's my list. And now I have to run through this function using this as a param. So if the length of a list is 0, this is not. If the length of a list mod 2 equals 1. So this is basically asking me, is my list odd in length? And it's not. So I'm dealing with an even numbered list. In that case, I'm going to be returning a list, rec of a list sliced from 1 to the end. So that means I'll be returning rec of a list, so from 1 to the end. So I cut off this one. So it'd be pt, okay, yz. Now the problem, once again, with recursion is I have no idea what this value is. So now I have to sort of start over from scratch and do the exact same thing I just did. So rec of pt, okay, yz, and start over. So is the length of my new A list 0? It's not. Is the length of it odd? So 3 mod 2 is 1, so it is odd. And now I'm going to be returning this. So sort of look through this. Looks like it's going to be a combination of 3 things. So the first one is a list containing, so let me write this down. We're going to return A list at 0. So let's see, A list at 0 is pt at index 1. So pt at index 1, that's just t. Okay. Oh, and then that's the only thing in that list, so there's no point putting the comma. So just t plus, then I make a recursive call to the same list but with 1 chopped away from the beginning. So in this case, I take away the pt, rec of okay, yz, and then just so it's easy for me to come back, I'm going to be looking at the same A list on my way back up the recursive chain, so I can just write this part down now. So it would be plus a list containing A list at 0, which is pt, at the 0th index again, so that would be p, first character. So a list containing p. Now I have to do the same sort of thing again where I solve this recursive call. So we'll be doing rec of okay, see. So same sort of stuff. We're going to do the exact same process. Is the length 0? It's not. Is the length odd? 2 is not odd. So we're going to return the same recursive call but with 1 chopped away. So rec of a list containing yz. Good. Now we're going to go ahead and figure out what this recursive call evaluates to. So let's go ahead. I'm going to write it down. Yeah, I'll write it down here. We'll do a wraparound sort of so we know the order. So making a call to rec of yz. So rec of yz, is it 0? The length 0? No. Is the length odd? 1 is odd. So I'm going to be returning a list containing, so a list at 0, which is yz at the first position, index 1. So that would be just z, plus rec list sliced from 1 to the end, so that would be an empty list. And now I can tell I'm about to hit my base case. Plus a list containing what? A list at 0, so yz at the 0th position. So that would be y, right? Good. And now in this case, I can just draw out another arrow. This is to rec of empty list. And from my base case, because this time I'm going to hit the base case right here, I see that the length of my A list is 0, so I'm going to return empty list. And now I can start going back up my chain. So we went from all the way from here, going down to here. Now we're going to go back up in reverse order. So everywhere I see rec of empty list, I'm going to replace it with just an empty list. So this would be z plus empty list plus y, which we know would just simplify down to being z y. So that is my final answer for rec of yz. So now I can stick this back up into here. So this just evaluates to z comma y. Then I come up here and I can substitute this value for wherever I say rec of okay comma yz, and I see that over here. So this would end up simplifying to t plus zy plus p as lists. So the final answer would be t, z, y, p. And then wherever I see this recursive call, I can substitute this value. And in this case, that's the only thing. So this ends up being the same, t, z, y, p. And because I've reached the start of my recursive chain, there's nowhere else to go, I know that this will be the final value of this function call that I made in here. So that means my final output would just be this right here printed out. So if I were in my shell, final output would be, and then I'm going to put the strings this time, t, z, y, p. So now we're going to continue on to the next recursion problem. So this recursive problem is similar to the last one. We just have to find out what would be printed to the shell after the following code is run, and then what is this code doing. So in this case, I just have to start from the function call, so I'm going to write that down. We're going to do the exact same technique we did last time. So rec of 72 and 12, and then we'll start from there. So keep in mind, first number is x, next number is y. So if y does not equal 0, so 12 does not equal 0, so I'm going to return another recursive call. So in this case, I'm going to return a recursive call to, and in this case, y becomes my first number, so I'm going to put this over here, 12, and then the next number is 72 modded by 12, so aka the remainder of dividing 72 by 12. Now in this case, 12 goes into 72 even 6 times, so that means there is no remainder, right? So I can just put 0 for here, and then we'll proceed. So draw that out again, rec 12, 0, and then let's evaluate again. So if y does not equal 0, well, this time y does equal 0, return x. We're down here. We're going to return x. So in this case, my x is 12. And now I've reached a base case. I no longer have any more recursive calls, so I can work my way back up the chain. Anywhere that I see a rec of 12, 0, I can replace with 12. And the only place I have that, because our chain is so short, is just here. So this ends up evaluating to 12, and because this is the answer to my first recursive call, I don't have anywhere else to go back up the chain. I'm just going to be printing out 12. So my output is 12. Now, in terms of finding out what this function is doing, this is actually the algorithm for finding the greatest common factor between two numbers. So this is greatest common factor. So in this case, the greatest common factor between 72 and 12 is actually 12. So in this problem, we have a sort of API trivia question almost. So the question is, after you have retrieved the JSON object from the request.getSomeURL call, what does getting a 200 response mean? So basically, if you've ever tried this, if you set a variable equal to a request.getURL, .get, I'll put it some variable here, and then you print out the result of that. So without converting it to .json or anything, you would see something that looks like response 200, where this number can be many different things. So in this case, this is a 200 response. And you will only ever see a 200 response if you successfully made an API call and got data back. So in this case, the answer is D. So just a quick reference, anything that starts with a 200 is usually good. So anything 200 is good. 400s are different. So 400 denotes that it's your problem. For example, the most common 400 error is if you've ever seen, you know, like a 404 page error, or if you've got a 404 when you try to make an API request, that means that you're trying to request a URL that does not exist, right? So that means you're doing something wrong. Another one would be like 401, which I believe is you're not authenticated, so you don't have the permission to access something, and so on and so forth. You don't really need to worry too much about these. And then lastly, there is 500. And 500 means their problem. So 500 error means that basically there's something wrong with their end. So their server is down, or their server encountered an error when it was running its code, something like that. Really nothing you can do to fix that. But to answer the original question, a 200 response is okay. So this next problem is an object-oriented programming problem, and all we have to do is just find out what would be the output of this code, so what's printed. We're going to go ahead and start by creating a new animal object. So let's go ahead and do that. I like to draw out boxes, so I'll say I have a Kermit box. And now I need to fill in its attributes appropriately based off of the class. So in this case, my class is animal, and everything up here is defined for the animal class. So when we create a new animal object, we have to go to the init method, right? So let's take a look at here. So self is the first thing, and then n. So n will be the string Kermit. So self.name is Kermit. The name is Kermit. Okay. Self.species is s, so in this case frog. For the last one, age equals a. So a is 13, but now hang on. The trick here is that notice there is no self dot in front of it. So we cannot assign an attribute for age, right? Instead, this age on its own is just a variable. It doesn't really do anything. You've just assigned age to be equal to 13, but we have no further operations with age, so it sort of just disappears. So in this case, we only have two declared attributes, name and species. So let's keep that in mind moving forward. Next thing we're going to do is Kermit.birthday. So what does birthday do? Well, it increments self.age by 1. So if I call this on Kermit, notice there is no age attribute to increment, right? Self.age doesn't exist. So in this case, I'm actually going to be getting an error because my object does not have the attribute age. And I don't know what the specific error would look like, the error message, but animal object does not have attribute age would be pretty close to what you'd be seeing in the output. So that right there is my final answer. Now, let's say this was correct, so self.age was a. In this case, we would have a age is 13. Then if I ran .birthday, this would become 14. Oops. 14. And then if I printed Kermit.age, my final output would be 14. But to reiterate, this is the final answer. This is our answer had it worked. So question 5 is an object-oriented coding question. The scenario is you're given a blueprint for a social media site, but it isn't finished yet. You want to add some functionality to your site by doing 3 things. Every time you create a user, you want to add that user to the social media's user list. Remember, objects can be passed in as arguments as well. So let's go ahead and do that one first. We're saying every time you create a user. So right away, that should trigger the idea of we need to be working in the init method, right? Because that method is called every time you create a user. So let's go ahead and do something in here. So we want to add this user to the social media's users list. So in this case, we are taking in a social media object from up here. And what we want to do is we want to add the user that we just created and put it in the users list for this social media. So the way we can do that is we can say, oops, social media dot users. So that'll get us access to this list right here. And then we want to append the user that we just created. Now this might be the kind of tricky part to think about. The variable that denotes the user we just created is self. So by appending the entire self, so in this case self is referring to the new user we just created, to the social media's users list, we have successfully inserted this entire object into this attribute up here. Okay, so now the reference for this object exists somewhere inside that list. So that's all it takes to add the new user to the social media list. So let's go on to part B. A social media object is equal if they have the same name. Create the double underscore equals method. So that's easy. All we need to do is go into the social media and then define underscore equals. And then, as usual, we take in two objects, right? The first one being self, the next one being the object that you're comparing to, the other social media object you're comparing to. And then all we need to do is just return the value of the comparison if self.name equals other.name. Okay, so that's all that takes, because that's the only basis for determining if they're equal or not. Let's go on to part C. Create a function called follow that allows users to follow other users by adding them to your following list. So notice it says create a function called follow that allows users to follow other users. So that's telling me this should probably go in my user class. When you do that, you want to make sure to add yourself to their followers list. However, make sure you're using the same social media or else print user not found. So to do that, let's go ahead and define our follow function. And for this, we're taking in self as usual, but we're also taking in the other person that we want to follow. And this time, other is referring to another user. Okay. So first thing we want to do is we want to see if you're using the same social media network or not. If you're not, then we can just print user not found. So if self dot social media equals other dot social media. And what's interesting here is that self.social media is an object up here. So that's why we had to properly define this in order for this line to work. Now that we're down here, let's go ahead and handle the else case first. So if they're not equal to each other, what we want to do is just simply print out user not found. Okay. That's easy. Now let's go ahead and handle the case of if they are on the same social media. So create a follow. When you do that, you want to be sure to add yourself to their followers list. So there's also followers and following. So obviously, if we just followed someone else, we should add this other person to our following list first, right? So self.following, which is a list, and we're going to append. This time we're going to append the entire other object, not just their name or username, the whole user object. Okay. Similarly, we're going to follow the instruction here. You want to make sure to add yourself to their followers list. So now we need to go to their followers list by accessing that attribute others.followers. And this time we're going to append self, because remember, self is referring to the current object. So when I follow someone, I will be putting myself in their followers list, and I'll be putting them in my following list. Big distinction between the two. So in this last problem, we'll be going over a tracing example that uses the code that we wrote in problem number 5. So let's go ahead and get started. So here we are creating a social media object twice, one for Instagram, one for Twitter. So let's go ahead and write those out on the side. So every time I create a social media object, all I do is I assign its name to be whatever name I provided, and then I give it an empty list of users. So let's write out Instagram for starters. So Instagram, the Instagram's name will be Instagram. And then its users will be an empty list. Then I can do the same thing for Twitter. So over here, Twitter, and then the name, Twitter, and then the users will be an empty list as well. Now down here in the next 3 lines, I'm going to be making some users, and we'll be using that init method over here to do so. So let's start off with Damien. So Damien will have a username attribute of Damien Henry. So for brevity's sake, I will just put U, and then we'll just say Damien Henry. He also will have a followers list and a following list, which are both empty lists. So I'll do F1 and then F2, both of which are empty. And then lastly, there's a social media attribute. And notice the social media will be assigned an entire social media object, not just a name or a string. So when I write that, social media, Damien's social media is the entire Instagram object. So to reference that, I'm just going to draw an arrow to this guy. Now the last thing we need to note is the final line of the constructor right here. So notice social media.users.append self. So when we append self, that's going to put this entire Damien object inside its social media's users list. So let's follow it step by step. So social media, in this case, social media refers to Instagram. .users refers to this list. We're going to append inside this list this entire Damien object. And to do that, I can just open this list up, and then I will write Damien inside. And keep in mind, this Damien is referring to the entire Damien object, not just a string. Okay, so we can close that up. And now let's do the same thing for Jasmine. So Jasmine has a username of Jasmine Choco. We have both of the followers and following list will be empty by default. And then we have a social media, which will also be Instagram. And as usual, we're going to append Jasmine, as in the entire object, to the same users list for Instagram. So now there's 2 users inside. Okay, and now we'll do Arvin. So Arvin is the username, Arvin Potter. Both of the followers and following lists are empty. And then social media this time will point to Twitter. And just like we did in the other two, we're going to have to add Arvin into the users list for its social network. And in this case, that would be Twitter. So right here, I'll put Arvin. Now we can continue. So print length of Instagram.users. So Instagram.users is a list containing 2 objects, so its length would be 2. I want to put some output down here. So right here we'll have 2. And then let's do the following methods. So Damien.follow, Jasmine. So let's look at follow. If self.socialmedia equals other.socialmedia. So we're comparing Damien's social media, which is Instagram, to Jasmine's social media, also Instagram. And to compare 2 social media objects, we have to look at the equal method for social media. And in this case, we just have to see if their names are the same. So in this case, Instagram does equal Instagram, so we know that they can follow each other. So self.following.append other. So self is referring to Damien, So we need to append other, which is Jasmine, to Damien's following list. And our following list is over here. So self.following will contain Jasmine. And once again, we are not just putting Jasmine as a string, we're putting the entire object in there. That's why we're doing append other. Then we go into other.followers.append self. So self is referring to Damien, other is Jasmine. So we go into this first list up here, because this is the followers list, and then we add Damien into this. Perfect. Now Damien.follow Arvin. So once again, we'll compare their social medias. So Damien's social media is Instagram, Arvin's is Twitter. So name of Instagram does not equal name of Twitter. So in this case, we're going to hit the else condition over here, and then we'll print out user not found. And then just to prove that this is the final correct output, because we reached the end of our code, I will be executing this in idle to show you guys. So I have the code that we wrote from question 5 along with the code from question 6 down here. And we can see that when we run this, we get the exact output that we anticipated.